Hello. So, I was thinking about the moon the other day. The moon orbits the Earth once approximately every 29 and a half days. It rotates on its axis, same amount of time, about once every 29 and a half days. So, you look up at the moon, you're going to see it's, while it changes phases, the surface is going to look the same. So all the dark patches on the moon will still be there. They'll just be how much of the moon can you see. Because again, it's turning at the same rate that it's revolving around us, so the same side of the moon is always facing us. When we talk of the dark side of the moon, we mean the side of the moon that is not facing the Earth. It is light half the time. A lunar day is half of 29 and a half days, basically. So I was thinking about this, and I got to wondering, I like astronomy, and I've studied some history of astronomy. So how would a civilization living on the moon have developed their astronomy? Would they have seen it the same as us on the Earth? Of course, instead of being, starting with a Earth-centered universe, they would have started with a moon-centered universe and stuff like that. But I got to let's speculate on this. I decided. Now, one important thing to consider here: Earth. Since ancient times, we've taken observations of the movement of the planets and the stars and all the other stuff like that. Usually it was very localized. It's, for whatever reason, national borders. We're at war with our neighbor, so we can only take observations from nearby. We can't take observations from their country or whatever's beyond their country. Limits of travel. Even all the total ancient observatories, they're all more or less the same place. Egypt, Babylon, throughout Persia, a little bit in Greece. The ones that were keeping records, at least. Was Stonehenge an observatory? People still argue about that, but they weren't keeping records. And so they were mostly, the ones keeping records were mostly in the same area. Not same area. Relative to the size of the Earth, they were pretty close to each other. So, we would have learned faster if we were getting information from other points on the Earth. And that's point 3 problem is, just because they were taking information from various points on the Earth, they weren't sharing it as much. Again, part of it was isolation, ancient world. Even up into the Middle Ages and Renaissance, scientists didn't want to share their data because they didn't want someone else making a discovery off of, I spend years and years taking data and then someone else looks at it and says, hey, Mars goes in this direction or whatever. And so I don't want someone else stealing my discovery, so I'm not going to share my data. And so they were, limits based on the fact that our data was coming from limited places on the Earth. The moon, on the other hand, now, they could still have, moon could have been broken up into nations. I'm assuming civilizations on the moon here. I'm not saying they were, but this is a hypothetical video. If there were different nations on the moon, then there would be limits on how wide and far they get their data from and how much they share it. If not, then they would be a lot more capable, at least, of catching data from all around the moon. No oceans, so exploration is easier. Most ancient civilizations knew that the Earth was round. And even throughout the Middle Ages, they had, They had the writings of the Greek philosophers and all. They knew the world was round. The idea that if you sailed off the Earth, or it was possible to sail off the edge of the Earth, was introduced in the 1800s by Washington Irving, and part of his short story. That's the earliest reference to people being afraid of sailing off the ends of the Earth. So, the bigger fear was you're going to sail out into the ocean and run out of food. Moon has no oceans, so they could explore the moon, know about the entire moon, take observations from various places if they, assuming that they get along with their neighbors all well enough. Still expensive to set up an observatory, but they'd be more able to, possibly. So there is the possibility they would have been taking data from different places sooner than we did, and been able to collaborate and find stuff out faster than we did. I bring this up because, like I said, Moon rotates at the same speed that it revolves. Same side of the Moon is always facing the Earth. So depending on where you are on the Moon, if you're living on the dark side of the Moon, you might not know the Earth exists. If you're living on the light side of the Moon, you know it exists. It's going to appear to be in approximately the same place. We go out and you can throughout the course of one night go out and there's the moon. An hour later, there's the moon, and it's moving through the sky. If you're living on the Moon, looking at the Earth's going to look like it's in pretty much the same place all the time. Unless you're moving around the Earth or around the Moon. But your backyard on the Moon, assuming you aren't moving around a lot, the Earth's going to look like it's in the same place almost all the time. Now, we do talk about things like the wobble of the Moon's orbit, stuff like that, and if you go and you observe the Moon long enough, you'll see, this month it came up on that part of the horizon, and next month it rose a little over here, and 2 months ago it rose. So we know it doesn't rise on the same place on the horizon. So we have reason to take measurements of the Moon's position over time, because we're curious. It moves around. How's it moving? To find that out, we have to take measurements. Again, on the Moon, the Earth is always going to appear in the approximate same place. And the wobble of the Earth, the Moon's orbit, and stuff like that does mean that the Earth is moving a little bit, but it's staying still in pretty much the same spot. So unless you live in a spot where there's a feature where you can observe the Moon with, or not the Moon, the Earth. So I'm living on the Moon, there's this mountain in the distance, the Earth appears above the mountain. Sometimes the Earth is right above the mountain, sometimes it's a little to the left, sometimes a little to the right. I might decide to start taking measurements and try to figure out what's going on with the Earth. If I live in a spot where the Earth is close to the horizon, then look, sometimes it looks like the Earth is touching the horizon, sometimes it looks like it's above the horizon. I might want to start taking measurements of the Earth's position. So, depending on where you are on the Moon, and assuming we don't have a network of observatories sharing data, some people are going to want to try to measure the location of the Earth, and they'll see, the Earth is actually moving in the sky. And other people, they have no reason to measure the position of the Earth. And so they may take them longer to see that the Earth is moving about in the sky. And again, someone living on the dark side of the Moon, if they have no contact with the light side of the Moon, they're not even going to know the Earth exists. And so where you live on the Moon and how well the information flows is going to affect the general consensus of your lunar astronomy, basically, your moon-based astronomy. So what else is going on here? Now the Sun, from our position on the Earth, the Sun and the Moon appear to be approximately the same size. sun's bigger. We know the sun's bigger, but it's farther away, so they appear to be about the same size. Throughout our history, we put more importance on the sun and the moon because they're bigger than. We knew the planets were moving, but they look like stars. They're little points of light. Sun and the moon are bigger, so our religion, our mythology, etc., we put more emphasis on the sun and moon because they were bigger. The sun, it's obvious, it became over time obvious that the sun was more important because, one, the moon goes through phases and the sun stays constant. And two, it's just, it's obvious we get heat from the sun. And it didn't take long to realize that we would probably die without the sun, and we can maybe survive without the moon. Maybe not, people still didn't know for sure, but the sun's obviously more important than the moon. Now, to people living on the moon, the Earth is going to be bigger than the sun. It's bigger than the moon, it's closer than the sun. What makes the sun and the moon look the same size to us on Earth would not make them look the same size to would not make the Earth and the sun look the same size to someone on the moon. The Earth would always appear bigger, if you can see the Earth. So, it might be considered more important. The Earth would go through phases. So that's, it would not be constant like the sun, but it would go through phases, and that could make it appear more mysterious because the Earth's phases are opposite the moon. So when we see a full moon, someone on the moon would see a new Earth. And then, we see the moon gradually getting smaller, they would see the Earth gradually getting bigger. So the phase of the moon and the phase of the sun are opposites at any given time. Like I said, that might just make the Earth appear more mysterious. Again, like I said, the Earth would appear to be in the same spot all the time. The moon, or not the moon, but the sun would appear to travel around the moon. Even though the Earth is going through phases, and so it doesn't look constant that way, it is in a constant position. So they might assume that the Earth is more important for that reason. Presumably, beings living on the moon would be able to survive in colder weather, just because it's colder on the moon. So the importance of the sun would be less so for heat or for living reasons. And again, the sun would be apparently go around the Earth-Moon system. So it might appear less important. All that said, what else do we have going here, though? People, their day would be longer. The lunar day would be about half of what we call a lunar month, because they'd have their backside or they'd have one side to the sun half the time, for, what is it, about 14 and a half days, 14 and 3/5 days, I think it would be, something like that. Not 3/5, 3/4, sorry. So again, if people were living on the moon, they would have to be able to survive without the sun for half of what we call a lunar month, which would be half a day for them. So the sun would be less important for that species. Earth would be, but again, if you lived on the dark side of the moon, you wouldn't even know the Earth existed. So its importance might be null. So again, a lot of this depends on, is the moon one big global, united group, and people know each other and they're familiar with each other, and they know that there is a Earth out there, whether they see it on a regular basis or not. That's going to affect a lot of stuff. Now we can like I said, we can see the light side of the moon. It looks constant. People drew pictures of it years and years and years ago. Dark side, eventually when we sent satellites up to orbit the moon and they took pictures and sent them back, we were able to map the dark side of the moon. Likewise, someone on the moon observing the Earth might try to map it. Difference being, we have clouds. Moon doesn't have clouds. So, Earth-based astronomer looks out, it's a cloudy day, I'm going to go to the bar. Not even going to bother breaking out the telescope. Moon-based astronomer looks out, there are no clouds from his point of view, pulls out the telescope, sets it up, looks at the Earth, and there is cloud cover on the Earth. They don't know until they set up their equipment whether or not they're going to see clouds or not. So, how much of the Earth's surface would they see? It depends on the weather on the Earth. That might get frustrating for them. And it would be weird because from time to time, when it is clear, well, the surface looks different. There's the coast of Africa. Next time we go and look, there's the coast of South America. And so the Earth would be mysterious to them. Again, once more, people have speculated whether there is life on the moon. Someone living on the moon looking at the Earth, their speculations of life on Earth would be a lot different just because the surface of the Earth from their point of view changes so much. And even we're assuming that when it's cloudy, they know that's cloud. Modern day astronomer on the moon might look back and say, yeah, it's cloud cover. Ancient astronomer or someone, Middle Ages, whatever, going back historically, would look at the surface of the Earth. They might guess it's clouds. They might not know it's clouds. It's again, they're dealing with old telescopes, or what we would call old telescopes. So their ability to tell, is this cloud cover or is this just a very weird shifting surface of the planet, is questionable. Spent a lot of time talking about the Earth itself. I want to talk a little about the other planets because that's where I was headed with this. So again, they would initially probably see a moon-centered, or they might recognize that the moon and the Earth are linked together and see a moon/Earth-centered universe. The inner planet. So Earth, the geocentric model of the Earth. We recognize that the moon was closest, so it had the closest orbit. We also recognize that Venus and Mercury were closer to us than the sun. So if you look at a picture of what they believe the universe looked like, there was the Earth in the center, then you had the moon, Venus, Mercury, the sun, then you go to Mars and the outer planets. Venus. So you look at Venus, or you try to look at Venus, because to see Venus and Mercury, you're looking towards the sun. And so they're hard to, before we had telescopes, they were very hard to spot, but the fact that people could see them and didn't go blind just trying to see them was amazing. After we got telescopes, it became a little easier, but you were still looking towards the sun. So a lot about there's stuff like retrograde motion, which I'll get to in a second. It would have been harder to notice retrograde motion of Venus and Mercury. The idea that they were going around the Earth and not going around the sun, and then the sun was going around the Earth, which is another possible model, it's sort of amazing. Why did we assume? Because it is, even though you could only see Venus and Mercury at certain times, it would be easier to associate them with going around the sun, even if you believe the sun was going around the Earth. it was just the concept that Earth was, more important, and therefore everything went around the Earth. But it is possible our history could have been different. Earlier scientists could have said, well, what if these go around the sun and then everything else goes around the Earth? And it would have still been questioned, but it would have been more acceptable than saying everything goes around the sun. Sort of go along at stages. And I'm saying this because Moon doesn't have an atmosphere. So someone on the Moon observing Venus and Mercury, they don't have the light refracting as it comes through, so they're getting things aren't bent out of shape as much. They might have been quicker to discover these two planets are going around the sun. And everything else might still be going around the Earth-Moon system, but Mercury and Venus are going around the sun, and then the sun is still going around us. So they might have gone a step ahead of us like that. Now, retrograde motion, that is where when we pass another planet, it appears to move backwards as we're passing it. That's assuming that it's going around us. Basically, we're moving, and as we pass it, it seems to do this little back and forth motion. That's assuming you're taking regular measurements. Again, how often would someone on the Moon, the Moon doesn't rotate as fast, or its day is shorter, so they would be taking measurements multiple times in one night from their point of view, whereas we would take like one measurement a night. So someone living on the Moon would be doing things differently than we would on Earth, and how differently they do it would affect how much more likely they are to discover something or less. They might never see retrograde motion because they only take one sighting a night. And so it takes them longer to recognize retrograde motion. Now another thing is, with the Moon going around the Earth, it regularly does retrograde motion on its own. Early way of trying to explain away retrograde motion was epicycles. We believe that the stuff was still going around the Earth, but they were big circles, and they were rotating around some invisible point. And so this epicycle, as it goes, sometimes, depending on where they are in their rotation around this imaginary point, sometimes they would appear to go backwards, sometimes they'd appear to go forward. The Moon goes around the Earth, so it is in an epicycle, basically. So there are times when it would be natural for them to see things going back and forth for no apparent reason. That might actually lead to them discovering a sun-centered universe faster. And so that was the point I was getting to, is, they would have initially seen things a lot similar to us, but their observations would have been different, which would have allowed them to take different paths, or force them to take different paths of reasoning than we did. And so a lunar-based society might have come across the heliocentric model of the universe quicker than we did, just because of where they're located. They are going around the Earth, which is going to force them from time to time to think of we're in motion. That's really it. Like I said, this is all speculation. Sort of trying to decide, how would an alien think? Or a moon-based alien, I guess, think. And it's obviously no way to prove it or not, but it's, expansion of the mind, They would have data they would collect their data in a different fashion that we would, so that would affect their view of the universe and their development of their view of the universe as well. And so that's it. I just got thinking about this the other day, and especially the point where the Earth doesn't move from a moon-based point of view. So how would that be looked at? And gone longer than most videos because this is all in my head and speculation. I haven't seen any books written on where anyone speculated on how astronomy would have, or the history of astronomy would have differed from a moon point of view. So I thought I'd think about it and share my ideas. And have a good day.